Hey, we're working through some more practice problems for the chain rule. Number 6 here is y equals the quantity of 3 plus x minus x squared all to the 8th. This is perfectly set up because it is basically a power rule, something raised to a power. So we'll let that inside part be a g or a u, whichever one you decide you like better. So we'll just apply the power rule. So y prime we'll bring the 8 exponent out front and reduce the exponent down to 7. So then we'll put our original g back in and our g prime on the outside, or our u, however you want to call it. So inside we'll have 3 plus x minus x squared, and on the outside we'll have 1 minus 2x. If you want to clean that up, you can, but make sure you have the right information. All right. Let's try number 7 here. So let's see what we've got. We've got h of theta equals secant theta squared. So that's secant times secant. The way that's written is pretty nice for the power rule. And then that's plus tangent of theta cubed. So once again, that is written nicely for the power rule as well. So even though we have trig functions here, we do have power rules because it's something squared, something cubed. So let's go ahead and do them in pieces. So h prime of theta will be, okay, so secant squared, so that means the 2 will come out front, and it'll be times the secant, because it'll be secant to the first, and the derivative of secant is secant tangent. Okay, so there is that g, and there is that g prime, or u if you like it. And then we have to go ahead and complete this, the tangent cubed. The 3 will come out front, and it'll come down to tangent of theta squared, and then the derivative of tangent is secant squared. So you still see the exact same thing with the rules there. Let's clean that up a little bit. So h prime of theta equals 2 secant squared of theta tangent of theta from the first one, plus 3, looks like tangent squared theta times secant squared of theta. So that looks pretty good there. Pause for a second. So number 8 is y equals the big square root of the fraction z minus 1 over z plus 1. So let's just go ahead and start off by rewriting that using an exponent. So we'll say y equals this big old thing to the 1/2, z minus 1 over z plus 1. Now that is a power rule part, because we got something fancy raised to the 1/2. So when we go to do that, we'll say y prime equals, and bring the power out front, 1/2, and the power will go down to negative 1/2. So we'll keep the z minus 1 over the z plus 1 on the inside. So that's the regular part of the u or the g. But let's come over, and because with the z minus 1 over z plus 1, you should realize that is a quotient rule. And in that case, the u is z minus 1, that's the numerator. The derivative of that is just 1, so u prime is just 1. V is z plus 1, that's the denominator, so v prime is just 1. So putting that together, we have v, which is z plus 1 times u prime, which is just 1, minus u, which is z minus 1 times v prime, which is 1, all over v squared, so z plus 1 squared on the bottom. So let's see if we can clean that up a little bit. So that'll be z plus 1 minus z plus 1 when we do everything. So it looks like the z's cancel out. So the top part looks like it's 2. So the outside part here that gets tacked on, we have the g or the u. Outside goes the u prime, or the g prime would be 2 over z plus 1 squared. So I'm sure there's different ways to clean that up, especially with the 2 on top and the 1/2 out there. But I don't know how useful it is to try and navigate all that. So in the end, what I came up with here was 1/2 and the quantity of z minus 1 over z plus 1 raised to the negative 1/2. And then all that is times 2 over z plus 1 squared. Okay. And if you want to clean that up, you're more than welcome to. Alright, problem number 9 here, y equals the sine of x times the natural log of 5x. So this is predominantly a product rule. So we'll look at this as a u and a v. So in that product rule, let's just kind of set that off to the side, product rule. U is sine of x, where v is the natural log of 5x. So u prime is cosine, that's the derivative of sine, and v prime, that's where the chain rule comes into play here, because we know the natural log of x is 1 over x, but when we put something in there, it'll be 1 over 5x times the derivative of that, which will be 5. So when we clean that up with that product rule, we can cancel out those 5s, no problem, but let's just put it back together. So we'll have y prime equals, so we want v and u prime, so let's just say cosine of x times the natural log of 5x. Okay, we'll just write that under here, u prime, v, maybe not the same order we're accustomed to. And then it'll be plus u and v prime. So that'll be 1 over x times sine x, and I did that a little bit backwards than usual, but it's fine. You can clean it up a little bit, but you get y prime is cosine of x times the natural log of 5x plus sine of x over x. So everything works out really nice there. And then let's try the last one on here. Hopefully it's not too hard. But we've got the tangent of the square root of x. So I'm just going to rewrite that. F of x equals the tangent of x to the 1/2. So feels like we might have a couple things going on here, but tangent is the main function. So what we have here is the u part or the g part as being x to the 1/2. Excuse me. So derivative f prime. So derivative of tangent is secant squared, and then our regular u or g will go in there, x to the 1/2. And on the outside, this is just a chain rule, so it'll be 1/2 x to the negative 1/2. So we get to put everything right back where it was. So here's our g prime. So if we clean that up, which looks like it'd be pretty nice with this one, we'll have f prime equals, looks like secant squared of the square root of x. And let's write that just a tad bit neater. And that's all over 2 square roots of x. And that square root of x on top is inside a secant function, so it doesn't negotiate directly with the square root of x on the bottom, so please don't cancel those out. Okay, so there's probably the best way to write that derivative. Alright, thank you.